Good morning, everyone. Today we'll talk about something that's called boxes and devices. All right, so for some of you, this would be some obvious information, but then you never know. And for some of us, this is going to be all new. So just bear with us. You don't worry, you will be challenged enough during this whole course. All right, boxes and devices. Here is the first slide. All right. So here's something what not to do. This would be something that if the inspector would see some kind of installation like that, he or she would probably lay an egg right on the spot and you would hear a mouthful. And if you did something like that, working for some company, you would also hear a mouthful from your boss, or you could lose your job. Right? Okay, so let's see what it is written here. It is written, so it shall be done. The CEC determines the amount of wires an electrical box can hold based upon the following things. Yes, those electrical boxes, they're supposed to hold an enclosed, well, multiple connections and wires that go in there. But we can't just do it at free will. There are some rules we have to go by. Basically, well, we need to, a box can fit only so much in it. Right? But we can't just say that make it good, as long as it feels good, then it's good. No, we have to go by some rules. So again, the CEC determines the amount of wires an electrical box can hold based upon the following things: the total volume of the box, well, makes sense, and we are considering the volume in milliliters. That's the unit that we use. And the size of the wires in American wiring gauge. The type and size of the device mounted in the box, because different devices have different, well, some of them are bigger, some of them are smaller, and of course the devices that are bigger, they take more space in the device box. So of course, well, we have to take account for that. So we can fit less wires in the box that contains a device that takes more volume, of course. For example, just a regular switch, light switch, would take less space in the box than something that's called a GFCI. And some of us know what the GFCI is, and we'll talk about that too, since we're ground fault circuit interrupt. And the number of wires, the number of wire connectors in used inside the box. I don't know about this sentence. The number of wires, the number of wire connectors in used inside the. I think that in should not be there. Okay, let's keep going with this. Here's table 23 of our electrical code. Now, mind you, I'm not teaching you the code. I'm just, sometimes I'll make a reference to it. The code lesson you're going to get during the code class with somebody else. I'm not sure who teaches your code this time. All right, so box dimensions and trade size. I wish that little thing would disappear, but I can't find a way to make it disappear. All the text that appears every time I hold the mouse over some picture. All right, so the box. Well, we have octagonal boxes, square boxes, round boxes, or otherwise known as device boxes. So 4 by 1.5 octagonal box, and this is just one dimension that supposed to be, so that's fine. Square box, 4 by 1.5 inch, or 4 by 2 1/8, and so on. So the square box would be it's just enough to give you the one side of that, because square will have all equal sides. So it's just enough to give you the 4 inches of the side of the box. And the last dimension that is there is the depth of the box. So some of the device boxes would have different, like 3 dimensions. Like for example, a device box, this one here, single gang box, 3 inches by 2 inches. So it's 3 inches by 2 inches. And this one is 1.5 inches deep. All right. All right. So, and then there is that table that shows you the capacity in milliliters, or in brackets, the cubed inches. So let's say device, the regular bread and butter, the device box that we have used, okay, will be 3 by 2 by, well, 2 inches deep or 1.5 inches. So the one that's 1.5 inches deep, 3 by 2, that will be the utility box that we have used already. It is the volume of that is 131 milliliters, and a milliliter is 1,000th of a liter. We all know that, right? So that's a unit of volume, and in brackets it's about 8 inches cubed. Now let's move along here. Let's take a look at this box here. Maximum number of conductors per gauge. You can fit 5 conductors in that box, up to 5 conductors, if you use 14 gauge wires. If you up the gauge to 12, so remember, the lower the number of the gauge, the thicker the wire is. So 14 gauge, you can fit up to 5 conductors in there. Thickness goes up, you can fit less wires. And here's the table to go by, so you can be legal, right? And the rest of the table just basically goes on just as I explained that to you, like right now. Table 22. Space for conductors in boxes 0, 12, 30, 24. Size of conductors in gauge. Usable space required for each insulated conductor. So per one conductor. Remember, I'm asking you to terminate those wires that are basically 6 to 8 inches from where it comes into the box to where it reaches the, let's say, screw terminal that we have used. That also plays a role, because if you have like 30 inches of wires, of course, how are you going to pack that thing in, right? So size of conductors in per gauge, 1 would use 24 milliliters. That is usable space required for each insulated conductor. So if you put this table together with that, it's going to make sense. Of course, if the gauge goes up, which means the wire goes thicker, which means the number of the AWG, American wiring gauge, is lower, the cable is, or the conductor is thicker, of course, it needs more usable space. You see, these numbers go down, these numbers go up. Once you download this presentation, just take a look at this thing and it's going to make sense. All right, now we're not going to go through this whole thing. I'm just going to I'm going to start you up on that, because the whole code is just like reading, well, some legal documents. And this is not a code class, but let's make a reference to some code content here. What do we have here? What's considered a conductor and what's not considered a conductor? Things have to be defined. Let's say what this number 1 point says here, the rule number 1. boxes shall be of sufficient size to provide usable space for all insulated conductors contained in the box. Well, basically, this one says we have to have enough space to fit what we need to fit in that space. And here's subject to following, of course. Okay. Now, as far as fitting wires in the box, here's the A subsection here. A conductor running through a box with no connection therein should be considered as one conductor. There's the word therein. Right? So it's almost like legal document here. Again, let's read this thing again. A conductor running through a box. So there's a device box and there's a wire coming in from one side and it just goes right through it, continues, and it just leaves the box. It is considered as one conductor. We count that one as one. It's not connected to anything. It just runs through the box. Comes in, doesn't even say hello to anybody, just keeps going. B, each conductor entering or leaving a box and connected to a terminal. So this one is connected to something. Or a connector within that box shall be considered as one conductor. So just based on these two, A and B, what can we say? Well, we can make two out of one. Because if we have a conductor that's running through the box and it's not connected to anything, just comes in and goes, and it's not connected to anything, it's counted as one. But if we cut that wire inside the box and make a pigtail out of it, now we got two. Let's go see conductor out of which a conductor of which no part leaves the box shall not be counted. So this is going to this A, B, and C. So if we have that one conductor going through the box, not connected to anything, it's counted as one conductor in the box. We cut that and we connect it to a, well, we reconnect it with a wire nut, let's say. Then we count those. Then all of a sudden, legally, we are considering that it is there are two conductors already. But also, if we cut that conductor and we have a short piece of wire and we connect that with the wire nut to one end of it and we connect the other end of that short piece to another one, that joining conductor, according to this here, is not counted. So we still have two conductors. All right, now here's number 18 and number 16 gauge. Fixture wires supplying a luminaire mounted on the box containing the fixture wires shall not be counted. What this is that, let's say you have a ceiling fan or some sort of like a light box that contains wires, light fixture, that maybe has has a little bit of a decorative kind of conduit or pipe going, a rod, and there's mounted in the ceiling, and there's some wires going in there to the box and whatever, and from the light, and they're joined at the device box. Sorry about the microphone. Those wires that are supplying power to the load, there's light bulbs, those wires are not counted. See, so this is how we read that thing. Not going to go through the rest of that. You will go through that when you study the code, but I'm just bringing your attention to that because we're talking about the boxes, device boxes, and using the wires and fitting the wires, conductors in the boxes. Okay. Now let's take a look at some of the boxes that we have. Right? As I said, to some of you, some things might be obvious, and some of us, we're still learning. So this is, it's a school, so well, we're supposed to teach that thing, so we are. Well, okay, so here is the SG, single gang device box. The one that we have used, the utility box that we already have used, it's also a single gang box. It's 3 inches by 2 inches, and the last dimension is the depth of it. Okay? So here is 3 inches, 2 inches, and this one is 2.5 inch deep. This one here can fit 8 14 gauge conductors according to these rules. Single gang device box, most common sizes: 3 by 2 by 2.5, 3 by 2 by 3 inches for GFCI receptacles. If you're just a regular duplex receptacle, it's fine. Use that 3 by 2 by 2.5. That's the depth. Now GFCI, do we have that here? See here? Here's a regular switch, and it occupies certain volume once you insert that in the box. Now look at the, well, this is not a GFCI, but this is a 4-way switch. It has a little bit more volume. Now GFCI would be even bigger inside. What GFCI is, it's a ground fault circuit interrupt. What it does, it has internal circuitry to sense that the current leaving, for example, the hot terminal, going through the load has to be equal to the current that is coming back onto the neutral. By the Kirchhoff's law, whatever comes out has to come in if there is no any other pathways, and there is not supposed to be any other pathways. If it's a light switch, the current is going to go out of the, well, if you plug in something, well, let's say tea kettle, all right? It has to leave the hut. It is going to go through the tea kettle, and is going to come back on neutral. So the current has to be equal, leaving and coming back. If that receptacle is splashed with water, for example, and the water is going to provide a current pathway to the ground from that duplex receptacle, then the current that is being supplied, that's going leaving the hot terminal, is going to be bigger than the current that is coming back, because some of the current has escaped through the water to the ground. So that means there's a trouble somewhere there, and that circuit is going to trip. That's, in a nutshell, that's what the GFCI is: ground fault circuit interrupt. It's going to, that circuit is going to trip. So those are, again, when you study code, you're going to find out where those GFCI rated circuits should be applied, and mostly it's going to be wherever there's access to water and there's certain distance of that. So all the bathroom outlets or the bathroom receptacles, all the kitchen by the countertop where there's access to water, they are supposed to be GFCI. But those, because those, well, this is not that one, but it's kind of looks a little bit bigger than just a regular duplex receptacle, then it is going to occupy a little bit more space, right? So that's why most common sizes. If it's just a regular duplex receptacle, yeah, it's okay to use a box that has less volume, because if it's not as deep as the 3-inch box, 2.5 is less deep than 3 inches, right? Still, we get single gang box. The single gang box, that 2 inches gives us, that means single gang. It's a single. We will go to that as we go along with these slides here. Then for the GFCI receptacles, for example, you're supposed to use bigger boxes because that GFCI receptacle occupies more space. What does it say here? Front face of the box extends ½ inch from the box. Okay, we'll get to that. Remember this, front face of the box extends ½ inch in front of the stud or for the drywall. See here? Not sure if you can see that under an angle. There are those stoppers here. We mount those boxes, and those boxes extend ½ inch in front of the stud. That's because the drywall that is going to be mounted on those studs, the thickness of the drywall is ½ inch. So when you put the ½ inch thick drywall and this thing sticks out ½ inch, those are going to become equal. These are going to be equalized in being nice and flush. So that's what this means here. Single gang device box cover plates, and sometimes they are called face plates. Well, nothing much to talk about here. Here's a single gang. Now, if there's a bigger box, twice as wide, it will be a double gang box. And sometimes you're going to have face plates like that. When you walk into some of the classrooms, you can see multiple gangable face plates, right? Like maybe 5, 6, 7, 8 light switches. So that 2 inches gives us the single gang size. And this would be the face plate for the cover plate for the duplex receptacle. And this would be a face plate or cover plate for the light switch. All right. Remember, excuse me. Let me just, I just had a class before you guys. So it's just 2 hours talking straight. Sorry. All right. The first one was the single gang. Remember, when you put two together, it's a double gang. 2 gang device box. Double gang. You see, here's 3 inches. That thing doesn't change. But now here, instead of 2 inches, we put them together and we have 4 inches. So that's a double gang box. So the double gang box would be 3 by 4, of course. 2 plus 2 is 4. And 2.5 inches deep. That can fit 16 of those 14 gauge conductors. All right. AWG, American wiring gauge. All right, so here's 4-inch square box. See, this one just shows 2 dimensions, 4 and 1.5. So that means the last one gives you the depth. And this one here is 4 inches because it's a square box. So of course you just have to give one side. So it's a 4-inch square box, 1.5 inch deep. All right. Not often used in residential wiring. Well, it can be. Exception for cable connections with no devices. Also known as a junction box. So you have a bunch of wiring going here, there, and everywhere, E-I-E-I-O. And you're going to have some sort of a common place where you're going to route some connections this way, that way, there. So you can use that as a junction box. So that's what it means here. 4-inch square box. Those are mostly used in the commercial, but you can. It says not often used in residential wiring. Exception cable connections with no devices. And then you just cover that with the blank faceplate, and that's it. It would be just like the first one that we had right on the picture, like this one here. But of course, this is a mess. There are too many wires here. Too many. You took too many. All right, there you go. Oh, it's the next box here. So that'll be the example of that. Except there's some connectors here, and not sure where this one goes. Is it through a connector? Yeah, of course. Then this will be whole fitted in and covered with the faceplate. And I'm not sure if this is correct here. Probably not. So it looks like some temporary installation here. All right, how much time do we have? We go to 3 gang, and we go to, we're going to go up to 50 gang. No, just kidding. So here's a 3 gang device box, or sometimes called triple gang. Look, that 3 inches stays here. And here is 6-inch, of course, 2, 2, 2, right? 3-gang device box, triple gang, that can fit 24 14-gauge conductors, all right? 4-gang, 4-gang box. Okay, so look, 3 by 8, 2, 4, 6, 8. So be 4 single gang boxes in one. All right, so that can fit 32 14-gauge conductors. All right, let's go here. There's some other specialized well, boxes. Like for example, there will be the recessed box here. And of course, because if you have a flat screen TV mounted on the wall, you don't want things to be sticking out. So if everything sticks out from the wall, then you're going to have to mount that TV a bit further. And especially in the residential setting and some commercial, the aesthetics actually do matter. So if you can make it look more pretty, then there you go. Right? So this would be a plastic 4-gang device box, and this is not just the power that's being, not just the service being applied here. So here's the power duplex receptacle, but there's some signal wires. You can see one coaxial cable. There's a phone jack and some audio speaker wires connected with that looks like RCA jacks. All right, there's some other example of that. If you go to some of the distributors here in where we are, or if you go to GTA, spend some time over the shelves and you can look at things, or if you're browsing on the net, there are different kinds to accommodate different situations, different kinds of boxes. All right. Now, gangable. Oh, gangable boxes. There we go. These are gangable boxes. What it means is you can take this apart just like Lego. You can disassemble one side or the other, and from one box and from the other, and you can just put them together so they look like this. It's a good idea to have those in your service van because you never know what situation you may encounter. Now, if you had a huge installation, huge project, of course, you would not utilize those for a huge project because you would purchase the already size of the boxes that need to be installed wherever they have to go. Because if you had a huge project and you got a bunch of those single gang boxes, those gangable boxes, then you would just lose time of assembling those things, right? But it's a great idea to have those because sometimes there's that oddball situation that you might have to do it, and you're supposed, and it's good thing that you can do it, as opposed to if you couldn't do it. Right? All right. Gangable boxes used, used mostly for adding devices on an existing installation, retrofit. All right, so where this thing is going here is, the best installation that you can have is a new installation because there's certain order of things. They lay the foundations and they put the framing, and then when the framing is there are different stages of mounting different equipment and whatnot. Right? So you have the whole thing, the whole structure open. The studs are there, excuse me, steel or timber, and you go in and you mount your devices. But sometimes you're going to find yourself in a situation and you have to do something that's called a retrofit. A retrofit is basically using part of the existing structure and adding on to things. And in some cases, well, you're going to walk in the situation that the drywall is already there, and maybe at the position that the box has to be, maybe it's not going to be as convenient because there's already some other furniture, maybe shelving or whatnot. And you won't be able to, we won't have that convenience of mounting that to a stud Plus, if we want to find the stud and mount the box to the stud, then, well, it would involve maybe maybe you will be required to do more physical damage to the wall than you want to. Right? So here's something that I'm going to ask you to do. See this here? It's called F straps, and write it down. Sometimes they're called F clips. There is a short, I think it's about 45-second video on YouTube that shows you how those can be installed. And these are wonderful devices. With these, you can install a device box right onto a drywall in between studs. So none of the box has to be mounted to the stud. And you can still install those device boxes like that. And what I say, cables for the retrofit are brought to the hole for the box behind the drywall by fishing the wall cavity from either above or attic, the basement. Okay, this is, yes, you have to bring in some wires some way. Okay. Common devices. How are we doing with time? All right. Common devices used with gang boxes. Well, here is a single pole switch. Single pole switch. Basically, it's a light bulb. It's a light switch used mostly for the lights, as a light switch. Single pole. Well, bear with me. And here would be a duplex receptacle, and you see some of the they call the decora. Some of them are square or rectangle, and they come with different face plates or cover plates. I'm just firing up my board here. A sec. This would be good. Click here, click there. Let's choose some colors for my pan. That should be good. Get a pan and bring this thing right here. Single pole switch. Here is a terminal. Here is a terminal. Here is a pole, single pole. Single throw. Single ball, single throw, switch, and I just threw something on the ground. And this could be a switch that accommodates a certain circuit. Single pole, that's what it says. Here's a single pole switch. And here's a duplex receptacle, which we have played with already. All right, now we're talking here. Remember when I talked to you about splitting the receptacle? Here is the tab that you can remove. Well, this person is removing it with the needle nose pliers. Pretty good idea. All right, so we have the hot terminal and we have the neutral terminal, duplex receptacle, 1, 2, duplex receptacle. And we have terminating screws or screw terminals. And they are connected here. So if you get this thing out of the box, brand new thing, those tabs will be intact. So it doesn't matter which you plug in, which terminal you use for the, well, try to use the one that is closer to the, like, you know, if it's a duplex, it doesn't matter. So the tab here can be removed. And remember, we talked about sometimes you can remove both tabs, but sometimes it's just enough. Now, then you have to make sure that you use the correct gauging when it comes to wiring. Because just remember, the busiest wire is the neutral. So you can make two circuits. It's a duplex receptacle. So if you have wires, here's a neutral, which goes to the neutral bar of it's basically a main return path for the current, and it connects to something that's called a neutral bar in the electrical panel. Okay. Now, you can have one single hot wire if the tab is intact, and both of these are on the same circuit. Sometimes you get 14.3, which would be 14.2, sorry. No, 14.3 here, because 3 current carrying conductors plus the bonding conductor. Right. So you could split those receptacles, and the neutral could be a common return path, but this here, this black hat, can go into one circuit breaker, which would be like 15 amps maybe. And the other hat, which would be red in this case, would be connected to another circuit breaker. So you could have 15 amps in here and 15 amps available for here. Again, you should watch the gauging, because sometimes you need to up the gauge of the wire in order to be able to do that kind of stuff. Or you can use 2 wires and split the other one as well. So you can do that. And then again, as a review, where will we use those? Most common use would be kitchen countertops, where there's a tea kettle, toaster, some blender and whatnot, and everybody wakes up in the morning, they go to work, they go to school, and everything is being used at the same time. So you need as many available circuits as possible, because if you plug in the toaster and you hit the blender and there's somebody else doing something else, maybe tea kettle is going, you would up those amps. That's all the that will be drawn from the electrical panel through those wires. And if it's more than 15 amps, then the circuit is going to break, so you can overload the circuits. So here's a duplex receptacle out of the box. The tabs are intact. You can remove those tabs accordingly. Okay, you can just do one, the hot one, and have a common return path, so leave that one intact, or you can remove both of them, but you have to have 2 wires. But well, this is more common practice that you just remove one. All right. Devices used with gang boxes. Here's a 20 amp, so the ampacity of this receptacle would be 20 amps. Well, wall unit or window unit air conditioner will have those, some of those, eh? And here is a 15 amp GFCI, ground fault circuit interrupt. Okay. And here are some buttons that you can see. One of them is a test. So if you want to see if this circuit, if the GFCI receptacle is in working condition, you just press the test and it should pop. So which basically should disconnect from the panel. If it doesn't, then maybe the circuitry that's inside is not up to date. Maybe it's had enough, right? That's why they have those. And sometimes when there's a ground fault, which means some of the current from this device escapes to the ground unwantingly, then that is going to pop. And when you correct the problem, maybe you will see what happens, and then you press that reset button. So here's a 20 amp GFCI and here's a 15 amp GFCI. Look at the footprint. The 20 amp device, such as air conditioning unit, will have a plug with this shape. There's additional kind of a shape here, which means, and something that we have to understand, a device that is rated for 20 amps, if it needs 20 amps, it is not going to ask for those 20 amps. It is going to try to pull those 20 amps, no matter what, from the, let's say, power, from the power supply, which would be electrical panel. And if the circuit breaker on that circuit is rated for 15 amps, well, that circuit breaker is going to trip. It says, yeah, you're trying to draw too much and none shall pass after 15 amps. So that's it, 15 amps at a time. Boom, I'm going to disconnect you, guy. All right. So those plugs are made so they cannot be plugged into the 15 amp receptacle. If you have a 20 amp device, you should use the 20 amp circuit duplex or receptacle. And remember, what else do we have to make sure? We also have to make sure that the circuit breaker at the electrical panel is also capable of providing 20 amps. It's not going to trip if it's more than 15 amps. So we have to get a different circuit breaker. And is that enough? And I'm going to answer my own question. Hey, it's Friday, might as well. It is not enough, because you need to make sure that the gauge of the wires between the circuit breaker and the receptacle is also capable. It also has the ampacity, which means the capability of handling certain amount of current. It has to have the ampacity of 20 amps. Otherwise, if you have the circuit breaker rated for 20 amps, you have this receptacle rated for 20 amps, and if you have thinner wire than you should have, you could find yourself in trouble. Basically, you can heat up those wires to the point that you can actually start a fire. All right, there are different footprints of different receptacles for different purposes. These here, they are not mostly used in homes built before 1960s. Slots are different sizes to accept polarized plugs. You can still see some of the buildings that have been grandfathered into the being legal, but you're going to see less and less and less of that. You need to have the bonding prong here. So this would be, somebody has the microphone on, please turn it off. So here is the 15 amp. Here, see, there's a 20 amp, and there's some different for the stove range or whatnot. Just take a look at this. I might ask you some questions on the test that will have to do with this picture, and you will have this available for download later on today, right after this class. Right. Oops. Yeah. Oh, that's the last slide for this thing here. You know what? We're going to stop here because it's 11:45. The second part we're going to go over quickly next time we see each other. All right, guys, gals, this is Friday. Don't do anything that you wouldn't write home about. Stay healthy and safe, and I will see you next time. And this is Bach signing off. If I can find the buttons. Here's one. I'm going to press that.